You coming in or not?
Yes.
Where's Grace?
Go
No.
back, go back.
No, you're not coming in. You just have to send me an email, remember?
Yeah, but I can say one.
Yeah, but
You can help me play the bingo.
whatever. 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 Here. This is your new maths book for semester 2. This is your lab book for physics. I gave you one yesterday, but that's a rough one. So before you write anything in this, you should show me what you wrote in the rough one, and then I can tell you if it's okay to put into this. Right? So this is the one you give to Sylvia. Yeah? And your maths book, the spine, you can take it from the other book, from semester 1. And you can keep one as well, okay? And wait, Grace wanted one as well. Can you give this one to Grace?
Yeah.
Okay. Now business is taken care of. We can resume the maths. So we're going to resume with more calculus. It'll come here now.
One page or the last one?
Show me.
The last one was 100.
It is not.
The last one was 100.
Yes. This is also 100.
90.
Page 1 starts here. This is page 0. There are 100 pages. You can check on the other book too. Okay. Of course it's not working because I haven't plugged it in. Alright. So, just a little bit of a refresher. If y equals x squared, everybody knows dy dx equals 2x. Yeah. If y equals, for example, ex, dy dx, ex. And if y equals sine x, for example, dy dx equals cos x. Just a little bit of a refresher. So it seems like we should be able to do this. I mean, we know what the derivative is for ex, don't we? And we know what the derivative is for cos x. But in fact, we don't actually know what the derivative is for ex cos x. So, you might think that dy dx equals, sorry, I should change this to sine because that's what I did above. You might think dy dx equals ex cos x. And if you think that, you'd be wrong. Okay, can I scroll down a bit? Well, these aren't really notes. Let me show you why it's wrong. So for example, if I have y equals x squared, I know that the derivative equals 2x. So this is true, this is the correct one. If you change y into x multiply x, and if you think that the derivative is this derivative multiplied by this derivative, you will get an answer which is wrong. It's not 1, it should be 2x. So the derivative doesn't work like this when we multiply. So we need to figure out how it works.
Simplify this thing.
We can't simplify this anymore. It's already simplified. But it's already multiplied. There's nothing else you can do.
So make x squared.
Well, in this case, yes, but not in this case.
Oh, yeah.
Okay. So let's try and find a rule for when we have a product, a multiplication. So we have, let's say, y equals fx gx. Now, do you remember the derivative? The definition is fx plus h gx plus h minus fx gx all over what? Yeah. This is the definition. Let's see if we can simplify this. You'll need to write this down. And the limit as h goes to 0. I can't. I asked them to move it, so they'll have to move it. I have no options unless I get my meter stick and whack it. No. Right. Now I'm leaving a big space on purpose. So this rule, it's not helpful because it doesn't tell us how we can find the derivative of two functions which are multiplied. So I need to simplify it. So there is a trick here. There is a way to simplify it. I'll show you the trick here. You have here, you put in here a minus fh g x plus h, and then a plus fh g x plus h. Now the reason I did that, well, firstly, what happens to the red and the blue? They cancel. They cancel. So, move down. Move down. I can't see people when you sit right at the edge. Move at least one space to the right. Okay. Red and blue, what happens?
They cancel out.
They cancel, as we said. So it's okay to add it in. But if you look at the first two terms here and here, what's in common? Gx plus h. You see, you have it here and you have it here. Yeah, you see? Here and here. Now, in the last two, what's in common?
No. G.
Oh, I'm sorry. I wrote. That's bad. That's not a H. So sorry. That's an X. Oh no. So what's in common in the last two? Fx is in common in the last two. So we can factor out those two and these two. Let's do that. So equals limit h goes to 0. Let me just put big brackets here. Fx plus h minus fx gx plus, what did I take out? Gx plus h plus, what am I taking out here? Fx, wasn't it? Fx, and then here I have gx plus h minus gx, and close. And all this is all over h. down one line.
Yeah.
So this equals limit h to 0 fx plus h minus fx all over h times gx plus h plus fx times, and this is over h as well, gx plus h minus gx. Who can tell me what this piece will become when h goes to 0? No,
If x goes
no,
0,
no. If h is 0,
goes 0.
if h goes to 0, what will this be? Not fx.
Everything is variable 0.
What will it be? It will not be 0. It will not be fx or minus fx or f0 or fx or square. What will it be? Anybody?
Don't say it.
I'll give you 10 more seconds.
I'll say 0. I'll stick to 0.
If you wish to be wrong, that's your choice.
Everything is variable 0 is 0.
If you wish to be wrong, that is your choice. I will not stop you. We all have a free choice to make. Anybody want to give me the answer? You're going to be disappointed. Here comes the answer. Yes, KJ, almost there. The derivative of f. By definition, this is the definition of the derivative of f, is it not? Yes, it is. So what happens when this h goes 0? This will just be gx. This will be fx, and of course at the end here, g derivative. So now you have your result. So basically, if y equals f multiply g, then the derivative is f derivative multiply g plus f multiply g derivative. And this is called the product rule.
Can I ask something?
Yes.
This is a basic rule. If you divide something by 0, the answer will be 0.
I'm sorry, if you have a problem with this, you can call up Sir Isaac Newton and complain to him that his calculus is wrong. Okay? Yeah.
This is right.
Dividing by 0 is incorrect. This is right. True. So what's your problem?
So why is there exception?
Because I'm not dividing by 0.
You said it h is 0.
As it goes to 0, not becomes 0.
Oh, it can be like 1 or 2 or something.
No, no. You need to review this lesson I did on the derivative, the first lesson on it. But I never said h, you're dividing by 0. You're making h go to 0, become nearly 0.
Oh, okay.
It's the first principles lesson. Do you remember first principles?
Yes. Yeah, it was confusing.
Watch the video again.
I know.
Hey, look, semester 2 final exam could include it because it's for everything. So just because it's in semester 1 doesn't mean you forget about it now. So if you have forgotten about it, you need to watch it.
Well, I know that they don't do it.
It's a long procedure, sometimes you get.
It's a long procedure, yes, correct.
Yes, the longest we go through.
It is, yes, but it could be on the exam.
And you lose.
So that's your life. It sucks, I know. But look, you just have to get through it. That's right.
Life is difficult.
As Grace used to say, life is difficult. She's not with us anymore.
But she's here.
In our heart, she said.
He didn't understand what he said.
Huh?
I'm just saying he didn't understand.
Yeah, he doesn't get my dark sense of humour. Okay, so let's have a look at some examples of using the product rule now. Can I spell that? Yeah. So product rule. So let's go back to the example of y equals x squared. What should the answer be?
Wait,
should be 2x. Let's test it using the product rule. So if this is f and this is g, the rule says first you do the derivative of f, which is what? What's the derivative of f here? 1.
1.
And then what's the next part of the rule? You multiply it by
Normal G.
g. Plus, what's next in the rule? F multiplied by derivative of g, which is 1. So that's x plus x, which is? Alright. So, this product rule, it works. So now we can use this rule for the question I gave you at the start of the lesson. Ex
and
sine x. So let's say y equals ex sine x. So this part is like the f, and then this part is like the g. So the derivative, so here's our first example. The derivative equals derivative of f, which is ex, times g, plus f, which is ex, times derivative of g.
That's the final answer.
Well, we can take the ex out.
Because not operated for Ax.
It is still ex.
So Ax. Okay.
So far. So far.
Exactly.
Do you think you could do this for tree functions? FGH.
Yes.
Yeah, so what do you think the rule is for tree? Derivative of y is f derivative multiply gh plus f, let's keep the letters in order, f, g derivative h plus so the derivative runs along each one by one. Yeah? So let's try a triple example. For example, let's say y equals x ex cos x. So y derivative, okay, derivative of x, so we'll do the x first. What's that? Don't be shy. 1. Ex cos x plus x, and now derivative of ex is ex cos x plus, and finally derivative of cos x. So that's x, ex, and cos x. What's the derivative of cos x?
Sin X.
Minus sin x. Minus sin x. Minus. So the answer is ex cos x plus x ex cos x minus x ex sin x. What's in common to everything here? Just ex. So we have ex cos x plus x cos x minus x sin x.
Sounds like physics lab. First experiment and then second experiment.
True. Yeah. Yeah. Fahad, question?
There's a minus sign, huh?
Yeah, yeah. There's a minus there because of the sin x.
Yeah.
Okay, you got this one? Yeah? Can I scroll down? Yes? Ah. Are we just waiting for Karar?
Plus X plus X minus X sin X.
Okay. Okay, what about something like this? Sine squared x.
Sin
Could we use the product rule here?
Yes.
We can-
How?
We can separate the signs.
Yes, explain more.
Sign into sin x. Sin
Sin x, sin
Please
x.
stop saying into. That means divide here, multiply.
Sin x multiplied by sin x.
Sin x multiply sin x, yeah. So you could change this into sin x, sin x.
Or
No, no or.
the way you said it is probably written on or.
Sorry, I'll do that again. You can change this into sin x multiplied sin x.
Because
And
you
then
said you can change. That means there's another way to change it.
there is another way to do it,
Exactly.
which we'll discover later. You should change this into sin x multiply sin x.
Yes.
And this will be f and this will be g. So the derivative of sin x, which is cos x, plus sin x, and again the derivative of sin x, which is cos x. So what will be the final answer here?
cos
True,
cos square
but
x.
you don't know that yet because I didn't tell you that.
Sin square x cos square x.
2 sin x cosine x.
Yes. We'll pretend that this is the only way to write it for now. Although Amanda did say that you can write this as sine 2x. But that is later. For now it's 2 sine x cos x. Because look, cos sine plus cos sine is 2 cos sine. You know, a plus a is 2a, that's all.
You haven't covered that yet, right? No.
Well, this is not. This is just normal algebra. The sine 2x thing we haven't covered. Okay? Right. Let me give you one to try. Oh, sorry, can I scroll down?
Yeah.
Yes.
Yeah. So, what I want you to do is find the
You want to go?
turning point. No, it's okay. The turning point of y equals ex sin x. What's turning point? What does that mean?
Divide x.
Yeah, go on. How do you find the turning point? What is the turning point? No, 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 no,
Maximum
no.
and minimum.
Thank you. So, how do you find this?
Divide.
D square y.
No, 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 no.
Or you put it in the formula.
No.
The formula, what you get.
No, no, no.
Make it
no,
is equal
no.
to 0.
Make what 0?
The question.
No.
The dy d of x is
Yes,
equal to 0.
yes, yes, yes. Make the derivative 0. Remember? Because at the top the slope is 0. Don't pretend you forgot this, okay? I know you didn't forget this already. We just did it 1 month ago before
No, we did it
Christmas.
like 2
We
days
did
ago.
it last year.
2 days ago we did it actually.
2 days ago.
Yeah, 2
They were
days
studying it.
Oh yeah, when I did the exam question.
Yeah.
Goodness sake. Right, so I want everybody to find the maximum point or minimum point here. What do you need to do first, Gerard? Find the derivative. And what rule do you need to use to find the derivative? Ah, well then you do know what to do, so do it.
dx, okay. Equal cosine x plus.
log 0 for? Cancel this? That's not how it works. Dude, forgot logs. Look, if I put log here, it's on both of them. So if you put a log here, that would be log EX plus log of this because it's a product here, like log AB. But don't put logs. Go back to this one.
You don't have to put logs?
Don't use logs.
Only with 0, right?
Continue. Wait, there's a plus here, isn't there?
Then we have to start.
Let's see. Now everybody's stuck on this line, huh?
See here, read.
Nobody knows what to do next.
After this?
After this.
Is that their final student?
EX. Why is these zeros?
Because sine 0. Rabbits 0 instead of x.
You don't have to.
No, you put this equals 0 and find x. You know this, Karar.
No, I don't know.
Yeah, you do.
We cannot use log.
You can use log. It won't help you though. It'll be no good to you. All right. Want to see?
Yeah.
You sure? You don't want to figure it out yourself? You'll be disappointed. You'll see it and you go, oh, of course.
No limit on it.
Right. Derivative here is EX sine x plus EX cos x. And we want it equal to 0. So we have EX sine x plus cos x equal 0. Now watch this. Now do you know what to do? I see those two in the middle figured out now as soon as I did that. KJ, no inspiration? What about if I do this? See what I did there? Yes. So this is like with quadratics. You have the two factors. It's just like that. So either the first one is 0 or the second one is 0. Now, in fact, this one is impossible because you can never find x that will make EX 0. So there's no answer here. So we only really care about this one. Any ideas here?
X can be x. No, I can.
Anybody?
Sin x is equal to cos x minus cos
Yeah,
x.
that doesn't really help.
X is equal to cos x over x.
Tell me how that helps.
Just making x constant.
Stop guessing things. Just think before you say something.
Sin inverse the cos inverse.
Again, thinking please. What is the problem with this? Why is it difficult? If there was no sin x, if it was only cos x, could you get the answer? Yes. If there was only sin x and no cos x, could you get an answer? It's because there's both, right? So, how could we get rid of one of them? No, we don't have sine squared or cos squared.
dy
Wait, hang on, Amanda's talking. Show some respect, please. Yes, Amanda.
Just see the sin s and plus cosine s like a whole half and use the formula.
What formula? Wait. Show me. No. Not this. Anybody?
second derivative. No.
Now you're getting desperate. Nobody?
Like x squared.
No. Divide everything by cos x. So you have sine x over cos x, but you know what that is. What's sine x over cos x? Tan x. So now you have tan x plus 1 equals 0.
Oh, I know this.
So tan x equals minus 1. So x equals tan inverse minus 1, which is minus pi over 4. To find the y would be equal to e minus pi over 4 sine minus pi over 4. Which would be, that's minus 1 over root 2 e minus pi over 4. So the answer is minus pi over 4 and minus 1 over root 2 e to the minus pi over 4. That would be the exact answer. KJ, give me an actual question, please, and not your confusion.
Okay, X and Y axis again.
You know what x and the y axis is?
Why you change tan to pi?
Tan inverse minus 1, I believe, is minus pi over 4.
Yes.
Is it not? I might be wrong, is it not? Check it.
It's good.
Minus 45.
What mode are you in? Minus pi over 4 yet?
Yep.
Okay, did you write this down? And does this make sense to you? Yeah? Okay.
Then
I remember seeing this question in the exam. You know, this is what in a product rule exam question could look like.
It's important. Yes, definitely.
Oh my goodness, yes. Yes, it is important. Can you if you remember here, this really is only the first answer for tan. How do you make more answers for tan?
Add 180.
And in this case, it'd be adding pi.
Yes.
Yeah? So can someone just put this in decimal form? What is that as a decimal?
45.
No, it is not, KJ.
Sorry, sorry.
Yes, decimals, not degrees. Sohi, do you mind? Can you give this to me as a decimal? And KJ as well?
Minus 0.785.
Minus 0.785, and then the y value?
Minus 0.322.
Yeah? Alright, let's have a look at the graph here. Answers off the screen. Yeah, what's your question?
Sine is sine of minus pi over 4 is root 2 over 2.
This?
I can't see.
Convert that into decimal and write it down.
Excuse me, how many?
Wait 1 second. Convert it into decimal and write it down.
It's minus 0.707.
Right, write that down.
Minus 0.707.
Okay, now type in what I wrote down. It was this, minus 1 over root 2. Alright, y equals, what was it? Ex cos x. No, sin x. Alright, let's plot this. That's not that exciting though. Yeah. There we go. Eventually. So look, anyways, I'll have to exaggerate it here, but you can see like the first turning point near the origin is around about here, which looks like it's about, I don't know if that's about minus 0.75 and minus 0.3, which is what it is. That's good. But you can see on this graph, if you look carefully, oh my goodness, what am I doing this way? There are more turning points. Like there's another one here at about 2.2. And if I keep zooming out, there's another one over here. And in fact, whoops, if I zoom out more, there's more turning points. And the reason there's more turning points comes down to here. Because you can make more answers here. Because the next one will be minus pi over 4 plus pi. And then the next one will be plus 2 pi plus 3 pi. Well, sorry, yeah, well it actually would be. But you remember for tan, the way you make the second answer is you do plus pi. And then to make more answers, you do plus 2 pi. So in other words, you can keep moving along pi units and you can get more and more roots. This is why the graph has this shape to it. Every pi units there's another root. So in the question I should have said, you know, something like the smallest x root, the one nearest to the origin. Yeah. Let's just go back to the graph here. So tell me, why is this graph increasing? Look, here it's quite flat, and then it suddenly starts to increase. Like if I zoom out, no, sorry, that's the wrong way. So why does the graph suddenly increase? What's the reason? Well, the reason is the EX gets bigger, yes? When the x gets bigger. So this is making the graph want to increase. What does tan do? Or sorry, what does sine do? Sine repeats itself. Sine goes sine goes 0, plus 1, 0, minus 1, 0, plus 1. So this is why the graph is going up and down, because the sine part is going plus and minus. And this is why it crosses the x-axis when the sine part is 0. But the e always gets bigger. So the e that multiplies the sine is making the whole thing bigger. Okay? So if you look here, this is wanting to increase to infinity as x gets bigger. And what does sine want to do? It keeps switching between going to 0, then to 1, then to 0, then to minus 1, then back up to 0. You know, it goes up and down, up and down. So this is the reason why the graph has this shape to it. So this will just keep getting bigger and bigger. Let's zoom out. Oh, error. Oh yeah. I think that's a good point to finish at. So I'll tell you which questions to do now.